Right, we're going to start now.
Analytics thing, I might need to format my second.
Thank you for coming, everyone. This is the third session of a three-part series in which we teach you the basics of blockchain technology.
It's a very nice
Session one covered the intro, like we just covered the basics of what a blockchain is as a data structure. And so we basically said, we just explained blockchain as a data structure such that it is an append-only database. So it's immutable, which basically means you can't rewrite the history of like the data of a database. And then we also explained the concept of decentralization. So you have no you have no handful or like one or two like entities that control the contents of the database, and instead you have multiple people who hold the contents of the database and also verify new information that comes into the database. And then we also explain how like basically databases run the whole infrastructure of the current world, and so they're important. And then we touched on like different properties and features such as scalability, which is what this session's about. And we'll define that a bit more in the upcoming slides. And then we also talked about the idea of a data structure being permissionless or permissioned. And what that basically means is if a data structure is permissioned, it basically means you have to have permission to access the database. And blockchains are generally permissionless, so anyone can read and write from the database. And then we expanded into like the reason as to why it's called a blockchain, and that's because you have slots of data, i.e. blocks, which are linked cryptographically, which chain the data slots together. And we also explained some properties of certain cryptographic functions, like hash functions. But I won't go into that today. If you wanna catch up to where we are right now, then consider watching the recordings on YouTube. And then last session we also talked about Ethereum. We had a guest speaker come in who directly works with Vitalik, who is the creator of Ethereum, and he basically talked a bit more about the architecture and the idea that Ethereum was the first blockchain that used what you call smart contracts. And so smart contracts are just self-executing code, it's like if-else conditions on the blockchain, and that basically unlocked what we call decentralized applications on the blockchain. And so the idea was you have an underlying architecture, the blockchain, the layer one, and then you have applications built on top of the blockchain that use the security of the blockchain. And smart contracts and blockchains like Ethereum are what basically unlocked the whole narrative around using the blockchain in global use cases and applications that you can use on your phone or your laptop. And then we also went into like the types of decentralized applications, and in this session we'll go into one specific vertical, which is decentralized finance, which is arguably the largest vertical or sector when it comes to decentralized applications. So what we'll cover today is the blockchain trilemma, and this goes into the scalability topic. And then we go deeper into that, and we talk about the state growth problem. And then at the end, we'll talk about an introduction to decentralized finance and different things you can do in DeFi and some benefits or why you should care about DeFi in general. The blockchain trilemma is basically a trade-off between three things. And every blockchain architect or anyone who's ever coded or created a blockchain has had to consider these three things. So decentralization, we explained that before, is the level, the distribution of control of the blockchain. And so, for example, you have some networks like Solana, which has 13 validators, and so that's 13 different people who validate the network and handle all the information coming into the database. Whereas networks like Ethereum have upwards of 2,000 validators, so it's much more decentralized. The concentration of power is much less, and generally, a blockchain should be decentralized. Otherwise, there's no point of having a blockchain, because you could just use some normal relational or non-relational database in which you hold a key to it and you're just reading and writing from it. Decentralization is one. Security is probably second most important, or probably as important as decentralization, and basically speaks for itself really. It's just how secure the network is. How can you prevent malicious people trying to change the contents of the database for their own benefit? And we talked about this in session 1 when we covered the Byzantine general problem. So yeah, I won't go into that, but if you want to recap on that, then maybe watch session 1. And then you sort of have the third, and you could sort of consider it secondary, even though it's not, but it's scalability. Yeah, and we'll define that a bit more, but generally it's about how can the blockchain cope with a large amount of users using it at one time. And that's basically what you require if you want global adoption on a blockchain. And the reason it's secondary is because historically speaking, like Bitcoin, Ethereum, and all these other layer ones, so underlying blockchain architecture, have always prioritized decentralization and security with the idea that in the future, they will try and solve the scalability problem. And so, yeah, it's sort of like we'll cross that bridge when we come to it. And we are at the bridge right now, given that we are at this chasm of, we're sort of early majority, but trying to get into the global adoption phase. And so most conversations around blockchain technology nowadays, especially if you're involved in the blockchain space, are about how do we scale blockchains and layer ones for global adoption. So I'll sort of go into some like properties or metrics that people use when looking at how scalable a blockchain is. And the first is throughput. So that's a measure of how many transactions a blockchain can process at a given time. And it's normally represented by a metric like transactions per second, or TPS. And then another one is time to finality. So the amount of time it takes for a transaction to be irreversibly added to a blockchain. So this goes back to like the whole immutability argument, where I mentioned in session 1 that blockchains tend to be immutable, which basically means you can't rewrite the history of transactions on a blockchain. But there is a bit of nuance with that because, for example, in proof of work, you can have chains that are reorganized because like you don't have a majority agreement as to which chain is the most valid. So sometimes you can have one chain, and then at time t you have one block, and then at time t plus 1 it splits into 2 different blocks because 2 different miners have produced what the network agrees as valid blocks. And so the chain splits, and then like you basically have 2 chains, and sometimes you can have more. And the idea is that as time tends to infinity, the network converges back to 1 block. But normally it's not to infinity, it's like 10, 20 seconds. And so that's what finality is. So some blockchains, you have to wait like 10 seconds for your transaction to be final and irreversible, and some are like 2 days. And so that's something to consider. Like for example, if you want to transact, like if you want to send money to someone, you probably don't want a transaction to be irreversible within 2 days, because that's just a bad user experience. If you want someone to urgently receive money from you, you'd want a finality of like 10, 20 seconds, or at least maybe an hour. The third one is block time. And so that's the time interval for every new block addition to the blockchain. I might go into this a bit more later, but like if, say, we increase the time that it takes for 1 block to be added to the blockchain, you probably, especially if it's a busy network and there's a lot of people transacting on the blockchain, then what happens is you get congestion because there's more information trying to be added into a blockchain, and a block can only have so much data before it gets added to the blockchain. And so what you have is validators who are looking at this new information. Their hardware on the computer can't handle all this information that's coming in, and they don't know how to pick what data goes into the block. And so in networks like Solana, you see a lot of congestion. The fourth one is block size, the amount of data a given block can store. And there's actually been like a very long debate in the blockchain space about what the optimal block size is, especially in the Bitcoin network. I think it was in 2017 or 2016, don't quote me, but there was an argument about whether they should make the block size larger. And what making a block size larger basically means you can input more information into a block, which basically makes it cheaper to use because it's all about supply and demand, right? So if you have a larger supply of space you can store data into, it's cheaper to store data into that block. And so you're paying less fees when you're transacting on the blockchain. And so like the original Bitcoin community, because they were very set on not changing the protocol, and then you also had a very small subset of the community who wanted to increase the block size because they wanted the blockchain to be more scalable. What happened is you had a fork, and we went into forks in session 1, and so you had a split in the chain. So you had Bitcoin, what you have now known as Bitcoin Cash, and then you have Bitcoin, which is the original Bitcoin. So yeah. And so, yeah, just going into the blockchain trilemma a bit more. Yeah, I sort of touched on some of these points, but I'll reiterate again. So if a blockchain is too decentralized, what you have is more entities, more people who are basically validating transactions, and that basically makes it slow because you have to propagate that information to a larger amount of people, and then you have to hear back from all of those people about their opinion, whether something's valid. And so if you become too decentralized, it's very hard to scale. And then yeah, so I also mentioned the more scalable a blockchain is, the more likely security can be compromised, and also decentralization, because if you reduce block time or you increase the block size, then you allow congestion to happen, and then the network shuts down. And so you see networks like Solana struggling with that. So like they've had a few periods in which the network has been down. And yeah, and then also you have if you have a larger block size, what happens is you have larger storage requirements. So I don't know if you know, but like validators have to store the blockchain on their computer or on some hardware. And so if you increase the amount of information that is coming in at a given time, then like their computer probably can't take it up to a certain point, after a certain point. And so what happens is the amount of people that can validate the network decreases. And so there's always a trade-off between like decentralization and scalability. And generally, yes, security has been prioritized. So yeah, it's always a trade-off between decentralization and scalability. And an example where like a centralized blockchain has faced the consequences is Ethereum Classic, which is a hard fork of Ethereum. And it suffered a 51% attack. And a 51% attack, for those who don't know, is when you have one entity who controls more than 51% of the electricity power of the network. And because Ethereum Classic is run by proof of work, it relies on electricity to secure the network. And so one entity controlled 51% of the network, and so it just had full authority over like all the transactions in the network, and so they can reorganize transactions in their favor. And yeah, and so I mentioned that it's Solana and Ethereum, but there have been a few layer ones in the space who are trying to tackle the scalability problem in different ways. So Ethereum, the guest speaker who came in last week, talked a lot about this, and yeah, so like they're doing a few things. So proof of stake consensus, even though that's not a direct scalability improvement, it did help in some ways. But the main ones are like sharding, and so it's like instead of having just one chain, you have like multiple chains that report back to the main chain, and it is a bit complicated, so I won't go into it. And then you also have like data availability solutions, which I also won't go into because that's a bit complicated. But generally, the idea is, like I mentioned before, Ethereum wanted to keep the security and decentralization on the layer one, and then they wanted to outsource the scalability to other layers. So you have what you call layer twos. So if anyone's heard of like Arbitrum, Optimism, ZK Sync, or Loopring, these are like famous layer twos that basically batch. So you have the layer one, Ethereum, and then you have the layer two, and their job is to batch transactions and send it back to Ethereum. And so batching transactions makes things more faster, but at the same time you still use the underlying security of Ethereum. I hope that makes sense. And And then for Solana, I mentioned Solana has a lot of problems with spam and congestion. One way they're trying to mitigate that is through fee markets. And so if you use a certain app that's very known, like it's known to be very busy or used a lot, they will increase the fees just for the use of that app. And that's very different to Ethereum, because on Ethereum, fees are based on the overall usage of the network. So demand and supply is not localized. And so if once a single app on Ethereum is being used a lot in a given amount of time and the fees spike, everyone who uses Ethereum has to pay that high fee at that given time. Whereas on Solana, they're going with a different approach, where it's like you have like different zones or like local regions of applications. And so if this sector of apps is going high in demand, then you only have to pay high fees if you use one of those apps in that certain region. And then Near have like dynamic block sizes. So the block size changes depending on how busy the network is, which basically helps smooth out transaction fees. And then Avalanche consensus is a very interesting one. In Avalanche, you have what you call, instead of having every validator validate new information coming into the blockchain, what the network does is every like time interval, it chooses a random subset of validators to validate the network, and then it's like they communicate through what you call gossip-based consensus. But again, I won't go into that. And then they also have the concept of horizontal scaling. So you have the Avalanche blockchain, but then you also have other blockchains built on top of Avalanche that use the validators on the original chain. It's a very interesting approach, and I encourage you guys to look into it. I don't know if you guys know KKR, the largest asset management firm, one of the largest asset management firms in the world. They recently tokenized their private equity fund, and they did it through an Avalanche subnet. And the reason they did that is because the pro of having an Avalanche subnet is that it's very customizable. So you can choose whether your blockchain is permissioned or permissionless, or how decentralized it is, but you still like use the underlying security of Avalanche. So yeah, we covered the blockchain trilemma. So I think I'll go into a very famous concept in blockchain called the state growth problem. And so what happens is, if your blockchain gains adoption and a lot of people start using your blockchain, and over time, what happens is that you have blocks added to the blockchain, and so the total information about all the past transactions grows, and that basically means all the validators of the network have to store all that information, because that's how you validate a blockchain. You have to download the history of the blockchain and then keep up with the new information coming in. But this causes a problem, because as time goes on, the amount of information you're storing on your hardware increases. And so right now, if you wanted to become a validator on the Bitcoin network, you'd have to store 400 gigabytes of data, and then that's increasing every day because you're also coping with the new information coming in. And so so validators become very slow in communicating, and it increases the time for validation. And then because there's so many more validators, the amount of time it takes for all the nodes to sync up with each other to have an agreed upon state of the network increases. And so there's been a lot of proposed solutions to all of these problems. The main one in Ethereum, I don't want to say the main one of them, is stateless clients. And so what you have is people who just store hashes or root hashes of different information, or just a block header. And we went into this last session. So yeah. Another approach Ethereum is going for is state tree pruning. And so after say a year of being a validator, you can delete everything before that year, because we all agree that information was valid, because everyone agreed on it. and then like you can just store that information in some centralized Amazon data center or something. Because to be honest, it's not that relevant. It happened a year ago. I say a year ago. They're talking about data that was added like 5 years ago. So even better. And then you also have data availability sampling. And that's a bit of a complex topic, but we do have Celestia Labs coming in spring to talk a bit more about that. And so we talked about the state growth problem, the blockchain trilemma, and so I think we'll go into automated market makers, and I will pass it on to Sean. Yeah.
Speak to this?
Yeah.
All right. Okay. So Emran talked about a lot of technical problems. Now we can talk about some financial problems. In session 1, we talked about how the current financial system in the world is centralized, a lot of data is opaque, and a lot of the solutions are needed to be made. And one of the initial application of blockchain when Ethereum first emerged back in 2015 was the idea of open sourcing finance. And how do you do that? You do it through DeFi. And one of the most important innovation in DeFi is called automated market makers, which is what we're seeing in the slide. So automated market makers rely on an idea of X times Y equals to Z, which is a constant formula. It was invented by Uniswap, which is that little horse you see, the unicorn you see on that corner. And they use a concept called the liquidity pool. The liquidity pool is essentially the amount of available liquidity in a set of trading pairs, such as say Bitcoin to US dollars. How much liquidity you have there would determine the depth of your liquidity pool. And the liquidity providers are usually referred to the LPs. They provide liquidity by depositing equal amount of 2 tokens into a pool, which the traders could use to trade against each other. So to give you an example, let's say if Bitcoin is at $20,000, if you want to deposit 1 Bitcoin, you also need to deposit $20,000 worth of some other coins in order for them to form a pair that you can trade with. And in return for providing your assets, you get a proportion of the fees of all these tradings. And some DEXs also provide these LPs with extra tokens through the yield. The reason why some dApps decide to do these is because when a dApp first launched, they don't really have too much liquidity providers. So in order to lure people into the loop, they have to provide them with extra tokens. And some people refer that to Ponzinomics, which to some extent is true. You offer people your native token, which is essentially worth nothing but for governance purpose. And people farm that token, and then they trade that token, and then they sell the token. Sometimes, if you do it incorrectly, it could cause serious problems to your tokenomics. But in most cases, people are fine with it. These tokens are usually just created and added to the circulating supply, which means that for all these incentives we give to the liquidity providers, usually it just adds selling pressure to the market. So below you see how liquidity provider and trader interact with each other. So the liquidity provider, they deposit their trading pair. In this case, it's going to be Bitcoin and BUSD. So BUSD is the US dollar stablecoin created by Binance. And then the trader is able to swap. Say, for example, they want to deposit BUSD into the pool, and then they could take out the Bitcoin. And then for doing so, they pay a fee. Usually this fee is about 0.3%, which is quite high if you compare to the centralized exchanges. But the upside of having a AMM model is that you could create any sort of trading pair. Unlike in Binance or FTX or any of the trading platform you use today, even trading 212, say for example, you need centralized entities to provide liquidity to you. But in AMM, anybody could become the liquidity provider, which gives everybody the opportunity to profit from market making. But how are these assets in the pool priced? So in the previous slide, we've mentioned the fact that you could deposit BUSD into the pool and then take out BTC because the trading pair was BTC to BUSD. Now, what happens if you deposit BUSD into the pool? Would the price of Bitcoin change? The answer is you follow the curve on the right side, which is essentially the quantity of a token in the contract compared to the quantity of the other token in the contract. And once you deposit any tokens into the contract, you move along the curve, and the curve's position determines what your price of your new token is going to be. And the first ever DEX, which we've mentioned in the previous slide, the unicorn called Uniswap, they follow a formula called X times Y equals to K, or sometimes referred to XYZ formula, where the price is determined by the following curve on the right side. And usually, if we don't have enough liquidity, what happens is you deposit some money into the pool, you shift the curve to the very bottom or the very top side, and therefore you kind of have a huge slippage. And that's not usually ideal for traders, because traders don't want slippage. They want to execute at the price they see. And that's why these DEXs, these automated market makers, they want higher liquidity, because more liquidity means less slippage. And so we've also mentioned in the previous slide, the liquidity providers, they earn a fee, which is 0.3% of your trading volume as their reward for providing liquidity. But does that mean they have no risk? They are just earning a risk-free yield? Actually, no. They have something called an impermanent loss, which is an inherent feature of automated market maker model. And this is something that occurs when the price of your token changes comparing to when you deposit them into the pool. And the bigger the change, the bigger the loss, regardless of the price direction. And the word impermanent here means that the losses are only permanent if you withdraw your liquidity providing position, which is essentially the Bitcoin and the BUSD pair, from the pool. Then your losses become permanent. And one way to reduce the risk of impermanent loss is to join the stablecoin pools, as their price is less likely to fluctuate. So what does that actually mean? So if you have a pool of, say, USDT, which is USD teaser, that's a centralized stablecoin, and you join that pair with BUSD, which is also a centralized stablecoin, their values are supposed to be pegged to the US dollars, which means they are always supposed to stay at $1. And for doing so, your price doesn't really fluctuate no matter what people trade at, unless they have like a huge deposit or huge withdrawal. And so you don't really have much price fluctuation, and therefore it leads to less impermanent loss. And usually for these stablecoin trading pairs, you also get less reward just because you take less risk. And for something which is much more volatile, say for example, the pair between Ethereum and Bitcoin, which both fluctuate quite a lot in price, your reward tends to be also higher. To give you an example of how this works, we can look at a pair of Ethereum and DAI. So at the beginning, we have $200. We deposit 1 ETH into the pool, which is worth $100, and then we deposit 100 DAI into the pool, which is also worth $100. They add up to be $200. Now, we have a pool size, say for example, you decide to take this pool, and then you decide to kind of deposit into another pool. That pool is 10 ETH and also 1,000 DAI, and then you basically own 10% of the pool. Now, say for example, if 1 DAI stays at where it is, where it usually should be just $1, DAI is another stablecoin which is issued by something called the MakerDAO. I believe that at some point we'll also go into how MakerDAO works, which is one of the initial applications of DeFi. But let's say if ETH decides to move its value to $400, which means it's worth 400 DAI now, then we are bearing a risk of impermanent loss. What happens right now is your yield farming asset becomes 0.5 ETH and 200 DAI. The total value is $400 US. But if you didn't deposit your 1 ETH and 100 DAI into the pool, then what you have is 1 ETH and 100 DAI, which is worth $500. In this case, you essentially made a $100 loss by depositing your asset into the pool because of the price change of Ethereum. And so why do we do it? Because we earn trading fees. It gives you 0.3% of every trade to the liquidity providers. And therefore, you bear a risk for earning the reward. To put it into perspective, if you look at any of the centralized trading entities, such as Binance, FTX, or Trading 212, they usually take a fee somewhere between 0.02% to 0.15%. So you're earning much more than the centralized exchanges, and for that you bear the risk of impermanent loss. This is a curve which shows you how do you how much money you lose as the price changes. So if you look on the very left side, if you basically go down to 0%, then you lose everything, which makes total sense, right? But if you go to 500%, which means that your price goes 5 times, then you lose 25.5% of your capital. What does that mean? Say, for example, if you initially deposit $1,000 into the pool, and now that $1,000 turns into $5,000, due to impermanent loss, you lose 25.5% of that $5,000, which is roughly $1,300. If you just held your assets, you wouldn't lose anything. But at the same time, because of all these price changes, people must have traded in the pool, and therefore you earn some trading fees. Now that's a game theory, whether you earn more trading fees than your impermanent loss. And some people build complicated models to model whether the returns would outweigh the impermanent loss. And so far we've talked about impermanent loss, liquidity providing, and how the curve moves. And that's essentially what Uniswap version 2 basically did. And that's the picture on the top right side. That's just a very simple, smooth curve. And then people started to wonder, is there a way for me to reduce my impermanent loss, or say we concentrate the liquidity? And that's where Uniswap v3 comes in. For Uniswap v3, you could choose to provide your liquidity in a concentrated range. Say, for example, if you have Ethereum, where the price fluctuates somewhere between $0 to $5,000, in Uniswap v2, you provide liquidity to all of these range. So no matter where the people trade in these range, you provide liquidity to them. And that means that you have a huge fluctuation in price. Of course, that means more trading fees for you no matter where people trade. However, you could also choose to do liquidity providing in Uniswap version 3, where you can concentrate your liquidity. So say, for example, right now the price of Ethereum is $1,600, and you think that the Ethereum would only trade in the range of $1,000 to $2,000 in the future. You could choose to concentrate your liquidity within this range. So only when people trade within this range that you earn trading fees, but also when people move out of this trading range, you stop providing liquidity and you just exit your position, and therefore your your impermanent loss also reduces in that case. It promotes your capital efficiency because if you think about it, if you concentrate your liquidity in the middle range, that means for every trade that executes in this range, you earn a fee. But if you spread your liquidity across everything, then that means for certain ranges, such as say $0 to $1,000, which is very unlikely to happen to have a trade, you have liquidity there, but they are not earning any fees for you. The more liquidity at the current price, but lower liquidity at prices further away is essentially what I've just explained in a wordy way. And there are other DEX experiments that are going on right now. One of it is called MEV protection. So MEV protection is a protection against what's called an MEV attack. MEV's full name is miner extracted value. That's essentially like the miners who order all these transactions, they could put your orders in a certain order. Say, for example, if I want to buy 1 million of Ethereum, if a miner sees that, he could put his order in front of me, or like say after me if he wants. So essentially what happens is the miner buys earlier than I am. He pushes up the price, I buys it, and then I sell it later, maybe say for example, and then he could also put his order before me, so he could sell before me. So he's always front running. If you're into trading, you know that front running is essentially illegal in centralized exchanges, but due to the nature of blockchain, people do this all the time, and this is something called the MEV profits. But that causes problems for the traders because you pay at a higher price than what you actually see. In order to protect that, something called the CalSwap is using what's called the batch auctions to prevent all these attacks. If you guys are interested in CalSwap, they have a very detailed white paper explaining how they do so. And then we've also mentioned the fact that you bear impermanent loss. One way to reduce it is to basically compensate all these liquidity providers with a token. Banker is doing so with their native token, but they've stopped doing so since June this year just because the whole market turned shit. And basically, if they issue their tokens to compensate their LPs, say for example, before the impermanent loss is $100, they issue 20 tokens that compensate for it. But now since the entire market goes shit, they need to issue 100 tokens to compensate for the LPs. So it becomes a death spiral. The more token you issue to your LP to compensate for the impermanent loss, the more likely people are to sell your tokens and your price of the token goes down. And then you need to issue more tokens for the future LPs. And that's why they suspended it in June 2022. And then there are also a few other experiments going on. One of it is called order book simulation. Order book simulation is what you use in centralized exchanges. Basically the same thing, but you move it on chain. And then futures, which is, say for example, something called the perpetual options. Options usually have a strike date. You strike it on a certain price at a certain day, and then you earn a certain reward. But people are experimenting with something called the perpetual options, where you have no expiry date, you have a strike price, and that means once you strike that price, whatever date you are, you could start to earn that profit. It's a very complicated financial product, and I don't really see it in the centralized finance world. Do correct me if I'm wrong, but it's something that DeFi is trying to experiment right now, which could be super interesting to add to a few, hedging positions and so on and so forth. And options, which is basically bring off-chain options to on-chain, that's kind of boring, to be honest. And then you have something called the cross-chain native swap. So we have all these different blockchains, and all of them have native tokens. How do you swap between them? Well, before SourceSwap came across, most people, they just say, for example, they have a Bitcoin, they send it to an exchange, they exchange it to US dollars, and then they buy Ethereum, and then they deposit Ethereum into Ethereum network, which is a very troublesome process. Now, SourceSwap, what they essentially do is they use something called smart contract locking your native token in one chain and releasing token in another chain. So you could just swap your tokens directly from, say, Bitcoin network to the Ethereum network, or from Ethereum network to the Avalanche network, and so on and so forth. It saves people time, essentially. And also, we've talked about the fact that in certain DEX, you don't have enough liquidity. What's one way to conquer that? You have something called aggregators. So aggregators, they look at all of the liquidities across all of the different trading venues, and they look for the best price to execute your trade. The example here is called 1inch, and they're the biggest DEX aggregator on the EVM compatible scene. EVM compatible is basically means that you could run the software in a similar virtual machine environment to Ethereum. And also there's borrowing and lending, just like all the commercial banks where you could deposit your money into it. Say, for example, I deposit my money into Barclays, they give me like a 0.5% interest rate per year. And then people also borrow from Barclays. They pay them, say, 1.5% per year. And this is how Barclays profit from commercial banking. They take your deposit and then they lend it out to other people. They make the difference in the interest rate, and that's their profit. The same idea is used on-chain. But unlike Barclays, which is very opaque, you don't really know how they're using your money. The on-chain DeFi protocols such as Compound Finance, you could see exactly what rate people are borrowing and what rate people are lending out. And the rate is dynamic in real time. Unlike the FOMC meeting, which is like a Federal Reserve meeting in the US, they changed the interest rate artificially. Here, your borrowing and lending is purely depending on your demand and supply. So if everybody is trying to borrow money, then your lending rate goes up, and therefore your borrowing rate also goes up. And the vice versa happens if the demand for borrowing and lending goes down. And then we have something super, super native to blockchain that you don't really see in the traditional finance world, which is called the flash loan. And how that happens is it allows you to take a loan without any collateral as long as the amount is returned within the same block. A collateral is something that you put down to borrow money from any sort of entity. So if I want to buy a car right now, if I want to borrow money from the bank, sometimes I need to put down my house as a collateral. So if I can't repay my mortgage or whatever, they will take my asset away and sell them so that the bank doesn't make a loss. The same concept happens here on chain. You need to put on collaterals to borrow. But what Flash Loan allows you to do is for you to borrow money without putting down collaterals. So you could just say, I have no money, but I want to borrow money. Is that possible? With Flash Loans, it's possible. But the only limitation is you have to return that money within the same block. Now, in session 1 and 2, we've mentioned the fact that Ethereum produces one block every 12 seconds. So what that means is, say, for example, at the start of the block, you borrow some money. After 12 seconds, you have to return it. That's written by code. So if you want to do any sort of Flash loans, it will automatically return your money within that 12 seconds. And there are many use cases for Flash loans. And there are also like protections, which is written there, which basically says that if the entire transaction is reverted, not accepted into the blockchain, that happens when you can't repay your loan, essentially. Flash loans, you could use it for arbitrage, collateral swapping, and self-liquidation. Arbitrage is when you see a price that's lower on one exchange and the price higher on the same on another exchange, but they're trading the same instrument. Then you can buy low at one exchange and sell high on another exchange. And collateral swapping is basically swapping your collateral from one asset to another. Put that into a real world example. If I put my house as a collateral, I could do collateral swapping and swap my house to, I don't know, like Gucci or Chanel bags if I have a lot of them. Self-liquidation is something that's very interesting. Let's say, for example, you borrow US dollars, USDT, using Ethereum as a collateral from this dApp called Aave. You borrow 500 US dollars using you borrow 250 US dollars of assets using $500 of collaterals. You have a collateral ratio of 200%. And usually when you go on Aave or any of these Compound or any of these, dApps, you have something called the collateral ratio liquidation threshold. That basically means if you reach a certain collateral ratio, you are in danger of being liquidated. And that means you have to pay a fee for not being able to keep up your collateral ratio. So in the example we've just given you, you have $500 that you put down as a collateral, you borrow $250. Now, if your collateral value go down to, say, $280, now your collateral ratio is below the threshold of 150%, then you are liquidated, and you pay roughly 10% fees as a fine for doing so. So how do you avoid doing that? Well, sometimes if you borrowed something but you've lost it in gambling or whatsoever, there is a way for you to actually repay that back by borrowing a Flash loan. So you borrow money in the same block as the block that you are going to return, which is basically Flash loan. You borrow that money, you return it to Aave, and then you unlock your collateral, which is Ethereum in this case. You sell your Ethereum, and then you exchange your Ethereum to something such as the US dollars, USDT, and then you use the thing that you've just sold to repay your Flash loan. And by doing so, you avoid the liquidation fee. And this is often used when people do leverages back in, say, March, April, and May this year, where the market basically turned very shit. Everybody was using self-liquidation, and there was many DeFi tracking boards which showed how many people are doing so. And the overall benefits of DeFi is that it's very permissionless. Like I said, you could become a liquidity provider and earn your fee. Anybody could do so. Unlike in traditional finance, only certain certified people, say market makers, such as, say, Optiver, Flow traders, or that we know of, say, Goldman Sachs, JP Morgan, all of them are market traders. Market makers. They all need a certificate. They all need to be trained to become a liquidity provider. But in DeFi, anybody with an asset could become a liquidity provider thanks to the AMM, automated market making model. And there is no remittance fee, which means that there is no middleman like the banks or any sort of traders who takes a cut from your trading fees. Composability is something super cool as well. So instead of each bank having their own siloed tech stacks, you could interact with multiple different protocols with just one wallet address. And what does that mean? You could have one dApp that allows you to do leveraging, one dApp that allows you to do borrowing, the other dApp allows you to do trading, and another app allows you to do options. You could combine all of them together. You could borrow from one dApp, use it to leverage, and then you trade on another dApp, and then swap that thing for options. So there's a lot of composability you could do here. But in the real world, in the TradFi world we kind of live in for now, for the actions which I've just mentioned, you need to go through roughly like 50 times of compliances from different departments in the States, in Cayman Islands, in the UK, and so on and so forth to get it signed, pay hefty fee, and be able to execute the trade like I've just mentioned. And also it gives you easier forex. This allows many people in developing countries to access, DeFi applications that are usually not accessible to them. So say, for example, for say my family who lives in China, if they want to access US banking or if they want to hold any US dollars and lend it out and so on and so forth, it's almost impossible because all of the regulations in place. But with DeFi, that's all possible because everything's on chain, everything's permissionless, anybody could do it. And I believe that's it. Thank you for listening. And
does anyone have any questions? We're finished a bit early, so if anyone has any questions, feel free to shoot them. Yes.
So, I have a question about flash loans, and you need to return the money that you borrowed within the same block. How does it? Because 12 seconds could be not enough, for example, for ETH.